Okay, I know that you might not be completely finished with that, but I'm going to go ahead and start talking so that we can get through all of this. Remember, you have your Chapter 7 homework. That's the linear homework that we did before spring break. You're not doing all of Chapter 7. We're just doing pieces of Chapter 7. The same is true for Chapter 5. We're not doing all of Chapter 5. We're just doing pieces of Chapter 5. Okay? So this is our Chapter 5 work, and that's going to be the due the day you take your test. Okay, and your test is going to be over parts of Chapter 7, parts of Chapter 5, and a few parts of Chapter 6. So it's kind of a little hodgepodge topic area, okay? Chapters 5 and 6 go really well together. So I think you'll see that. And then the Chapter 7 stuff, hopefully you remember that from before spring break. So, and that test is going to be on Wednesday, April 24th. Okay? That is your test. Is anybody, the final, is it that Tuesday the 30th?
Yes.
Okay. And so then your final is Tuesday, April 30th. Okay? That seems late for me that you're allowed to have... I'm going to erase this right here. I need to confirm that. Because there's a week that's a dead week. Do you guys know what I'm talking about? Where you're not supposed to have any tests or quizzes. April 24th seems late for that. I need to look that up. Because if it's a full, if dead week is a full week before the final, then it should be April 19th. Okay. Let me check on that, okay? I need to find out for sure when dead week starts. Okay? So, that's where we are. So, properties of exponents. Now, I know that we've talked about these some, and I want you to realize you do not need to have these names memorized. You don't have to look at that and say, hey, I'm using product of powers. What you have to have is you have to have you have to know what to do with the exponent. You don't have to know which property you're using, but you need to know the general rules. You don't have to then put it back to the actual name. Okay? So I just want to make sure that you're aware of that. Now, product of powers, that is when we are multiplying two together that have the same base. What's my rule? What do I do there? I add their exponents. So my rule here is I add exponents. Okay? So for this one right here, it is x, 2 plus 3, and what does that equal? X to the 5th. Good. Okay? Now, power of a power and power of a product very much interchangeably, well, they're not interchangeably, but you use them a lot at the same time. Power of a power, power of a product. Okay? Power of a power means when I have x to the 3rd power and I'm raising it to another power. That's what power of a power means. Okay? I am raising a power to another power. What do I do then?
You multiply the exponents?
I do. I multiply. Okay, so my key word there is multiply. Okay? And so this is x to the 3 times 4, and that is x to the 12th. Now, very, very often you are using power of a product and power of a power at the same time. Power of a product is when I have more than one thing inside the parentheses and I raise that to a power. okay? It's similar to the idea of the distributive property. It is not the distributive property, but it is similar to that. So power of a product means that that 3 belongs to everything in there. So I've got x to the third, and I've got y to the third, okay? What happens is I may have something like x squared times y to the third raised to the fourth, okay? In this situation right here, I am using power of a power and power of a product at the same time, because I have x squared raised to the fourth power, so I get x to the 8th, and I get y to the 12th. So realize that power of a power and power of a product you use at the same time. The same is true when I have power of a quotient. I'm very often using power of a power and power of a quotient at the same time. Okay? Power of a quotient means I've got x over y raised to a power. So I have to give that 3 to both the x and the y. So for power of a product and power of a quotient, what we are doing is we give exponent to everything inside parenthesis. Okay? That's what power of a product and power of a quotient. Now again, we also use power of a power when we are doing those. Those very much go together. So if I have x squared over y, and I'm raising that to the fourth power, I've got to multiply this 2 and this 4 right here to give me x to the 8th. So that's using power of a power. Okay? Okay. Quotient of a power. Quotient of a power. What's happening there?
Division.
We divide, but what do we do with the exponents? Subtract them. Good. And they've got to have the same base. So if I have x to the 5th over x to the 3rd, that is x to the 5 minus 3, or x to the 2nd. Okay? I am subtracting exponent. Okay? Now, those hopefully are a review. Hopefully you remember that from chapter 3 when we started doing polynomials and stuff. We used those quite a bit when we were simplifying rationals. Okay? Now, we briefly talked about negative exponents at that point. A negative exponent means reciprocal. Okay? A negative exponent means reciprocal. So if I have x to the negative 2, where does that go? Where does it go? It goes where? It goes to the bottom. So then I have 1 over x squared. Now, what if I have y to the 2nd over x to the negative 3? What happens when the negative's in the denominator? Where does it go? It does go to the numerator, okay? So this becomes y squared x to the 3rd, okay? So negative exponents, if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. That's what negative exponents do. Okay? Now, exponent of 0. So if I have x to the 0 power, what does that equal? 1. It equals 1. Okay? Now, if I have negative x to the 0 power, you are going to ask yourself, what is being raised to the 0 power? Everything inside that parenthesis is being raised to the 0 power. What's in front of that x? Negative 1. Okay? So here the negative 1 is being raised to the 0 power, and the x is being raised to the 0 power. So that equals what? Everything in there is being raised to the 0 power. It's actually positive 1. Let me show you the difference here. Okay? So, here I've got negative and x. It's inside parentheses. Everything in the parentheses being raised to 0 power. If I have negative x to the 0 power, what's in front of that x? Negative 1. What is being raised to the 0 power here? I heard it. Just the x. Okay? In this situation right here, just the x is being raised to 0 power. So this problem is negative 1 times 1. And that gives me negative 1. For this problem right here, this problem right here, everything is being raised. The negative 1 and the x. So negative 1 to the 0 power is 1, and x to the 0 power is 1. So that is essentially 1 times 1. Because anything to the 0 power is 1. The question that you have to ask yourself, and this is pretty much in general, what is being raised to the power? What is being raised to that power? That's what you want to know. What is being raised to the power of 0? What's being raised to the negative power? What's being raised to the power outside the parentheses? You've got to ask yourself that question. Okay, are we ready to try some? Okay. Here we go. So for this one, we're going to use product of powers. Product of powers. When we use product of powers, we add the exponents. We add the exponents. So I am going to take x squared plus negative 5. What is x raised to 2 plus negative 5? Negative 3. 2 plus negative 5 is negative 3. So we have x to the negative 3. Now we're not done because we need to deal with this negative exponent. Where does the negative exponent go? To the denominator. Okay? And it becomes x to the 3rd in the denominator. What am I left with on top?
The 1.
Just the 1. Not the negative, just the 1. Okay? So the answer, the final answer here is 1 over x to the 3rd. Now, you could do this a different way, and that's okay. Okay? Some students look at this and they see x to the squared times x to the negative 5th. Some students want to deal with that negative 5th first. So then it would be x squared over x to the what? 5th. Okay? At that point, I have x times x in the numerator, x times x times x times x times x in the denominator. And what am I left with? And is that okay? So you can go about a lot of these in different order. Okay? Just so you know. Okay. Now, this is a power of a power. So, and again, you don't have to be able to identify these. The only thing that you need to know about this is what do I do with the -2 and the 4? What do I do? Multiply. That's all you need to know. Okay, you don't need to be able to say, Alicia, I'm using power of a power on this problem. Okay, so I've got x to the -2 times 4. So that is x to the what? -8. Okay, I'm not done. Where does that go? Excellent. Okay. This is the way that I would solve that. I mean, the 1 over x to the 8. I think that's the most straightforward way to solve it. You could do 1 over x squared to the 4th power. Do you see that? I dealt with that negative exponent first, and then I moved it to the denominator. I would still end up with 1 over x to the 8th. But I think this is the better way to do it. This one right here. Okay? But I want you to realize that both are acceptable and you get the right answer. But in general, the one on the left is what I would recommend that you do. Okay, now we're going to kind of put some more stuff in it. So take it step by step. So our next one, I have x squared y to the -3rd, and all of that is raised to the -4th power. This is where we're using power of a power and power of a product. This is where we're using those two things at the same time. So that -4 belongs to everything in the parentheses. So I've got x to the 2 times -4. Then I have y to the -3 times -4. Now, in this situation, students might look at that y to the -3rd and think, I want to just go ahead and deal with that negative exponent and put it in the denominator. Students might want to do that. However, what do I have on the outside? I have a negative exponent on the outside. So my positive exponent, my x squared, becomes the negative exponent. And my y to the -3 becomes what? My positive exponent. So you're just going to be moving a bunch of things back and forth if you do it that way. So the better way to do this one is to go ahead and give that -4 to everything in the parentheses. Okay? So I have x to the -8 and y to the +12. So my y to the 12th stays in the numerator. It's my x to the -8 that goes to the denominator. Okay? So then I have y to the 12th over x to the 8th. We doing okay? Can I go to the next one? Okay. This is another situation where I would go ahead and give that -2 to everything inside the parentheses. For this one, we are using power of a quotient and power of a power. So we've got to give that -2 to everything in there. Okay? So I have a to the 3 times -2, b to the -5 times -2. Again, our negative exponents in this problem become positive, and our positive exponents become negative. So you don't necessarily want to move everything around before you deal with that negative exponent on the outside. It's just a good habit to get into to go ahead and deal with that first. So then I'm left with a to the negative 6 and b to the 10. My b stays in the denominator. Where does my a to the negative 6 go?
It goes to the denominator.
It does. And what am I left with on top?
1.
Good. You are not left with 0. And that kind of goes back to our rational stuff that we did last chapter. You know, when everything cancels out, you're left with a 1 on top.
So,
Yes, ma'am.
why does the 10 stay? What does the b to the 10th power stay in the denominator?
Okay, so here we have b to the negative 5. I am raising b to the negative 5 to the negative 2. When I multiply those two together, I get a positive exponent. Okay, so if I moved it, and I don't really recommend doing it this way, but I could have done, I could have moved that first before I dealt with the negative 2 on the outside. I could have said a to the 3rd, b to the 5th to the negative 2, but then I would have just had to move it back. So then it would become a to the negative 6th and b to the negative 10, and I'm moving it back to the bottom. It's okay. It's mathematically correct to do it that way, and if that's how your brain works, then that's fine. If you go ahead and give that negative 2 to everything in parentheses first, then you're not moving things twice. Good question. Okay. Now, this is another situation about moving things around. Let's talk about what this means, and then we'll talk about probably the most efficient way to do this. Because I've got x to the negative 4th on the top and x to the negative 2 on the bottom, if I wanted to go ahead and simplify that, I would take my x to the negative 2 and move it where?
To the top.
Good, and it becomes x squared. My x to the negative 4 goes to the bottom and becomes x to the 4th. What that means is x times x over x times x times x times x. Cancel, 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 cancel. So this is what's happening here. Okay, I move my numerator to the denominator because it's a negative exponent. I move my denominator to the numerator because it's a negative exponent. Now, this is quotient of powers. When I have quotient of powers, what do I do? What operation do I do with my exponents?
Subtraction.
I subtract. I subtract. So I would do x to the negative 4th minus negative 2. Minus a minus becomes positive. I'm left with x to the negative 2. So I get 1 over x squared. Okay? This way right here, you are using the properties of exponents to solve. That's the most efficient way to solve it, using the properties of exponents. Okay? You certainly can do it the way that we did it on the left. But I do want you to be aware that we can use the properties of exponents from the very beginning. Okay. Our next one. We have 3x squared y to the negative 4th times 4x to the negative 3rd times y. Is there anything on the outside of those parentheses that I need to deal with? They're not, okay? is there any addition and subtraction of monomials in this situation? Now, I know we're going to be adding and subtracting exponents, but is there a plus or a minus sign in here at all? There's none. Okay, so what I do with this is I deal with my number first, my constant. I'm going to deal with that constant first. So that's the 3 and the 4. That's the coefficient in front of my variables. So I'm going to say 3 times 4. What is 3 times 4? 12. Okay? Then I'm going to deal with my x squared and my x to the negative third. I would use the properties of exponents because we are multiplying those. So what am I going to do with their exponents? Add. So I'm going to have x to the 2 minus or plus negative 3. Remember that plus negative 3 and minus 3 are the same thing. Because we are multiplying exponents together, I want us to do that plus. 2 plus negative 3. Okay? What is 2 plus negative 3? Negative 1. So I have x to the negative 1 power. Now I'm going to deal with my y to the negative 4th and my y to the negative 3. Oh, no, I'm sorry. It's not y to the negative 3. What is it? Y to the what? 1. Okay, remember, when you don't have an exponent written there, what's the exponent? 1. Okay, so then I have y to the negative 4th plus 1. What is negative 4 plus 1? Okay. Now, my 12 is going to stay on top. My x to the negative 1 in the numerator becomes x in the denominator. My y to the negative third in the numerator becomes y to the third in the denominator. Okay. Now, here, it's similar to the last problem that we did, except we're dividing, we're not multiplying. So we're going to follow that same general idea. Is there anything on the outside of parentheses that I need to give to everything? No, there's not. Okay? So, the first thing that I'm going to deal with are my 12 and my negative 3. 12 divided by negative 3 is what? Negative 4. You just forgot your negative. No, you're good. Okay. Then, I'm going to deal with my a to the third and my a to the negative 1. This is division. When we divide exponents with the same base, what do? Good. So I've got a to the third minus negative 1. A to the third minus negative 1. So negative, negative, what does that make? Positive. So that becomes a to the 4th. Okay? Then I'm going to deal with my b squared and my b to the 5th. I am subtracting those exponents. So I have b to the 2 minus 5. What is that?
-3.
Good. Okay, so I have b to the negative 3. Now, I always look at this and say, is there anything else I need to do? Is there anything else that can simplify out? Is there another step that I need to take? Is there? Yes. What do I need to do? Got to bring it to the bottom. So my negative 4 stays in the top because that is not an exponent. Whoops. Okay, the -4 is just a number. It's not an exponent. It's a coefficient to all that. So that stays in the numerator. Okay, so if I've got 4x to the -4th, if I've got -4x to the -4, this -4 is my coefficient. This -4 is my exponent. You only move it to the bottom when you're dealing with an exponent. That -4 right there stays in the numerator. Okay? Okay. We have a lot going on in this one, right? A lot. We are using negative exponents. We are using power of a quotient. We are using power of a power. We're using lots of things. Now, you could, if you wanted to, go ahead and do 15 divided by 5. Okay, you could. You could bring the x to the -1 to the bottom. I mean, you could simplify what's inside first. That would be an okay thing to do because you've got so much going on inside. Or you could give everything the -1. You're going to get to the same place no matter what. In general, I deal with that negative exponent first on the outside. That's typically what I do. I'm going to show you both ways just so you'll have exposure to both. So this -1 goes to everything. It goes to 15 to the -1, x to the -1 times -1. What's that going to give me? It's going to give me positive. So -1 times -1 is positive. Y to the second to the -1 power becomes y to the
-2.
Good. Now, in the denominator, it goes to everything. I have 5 to the -1, x to the -1. Then I have -4, -1. What's that going to be? Good. Okay, now I'm going to deal with those negative exponents. And I'm going to circle them just so we can look at them. I've got to move this to the denominator. I've got to move this to the numerator. Okay, I'm going to go ahead and do that. So I have 5 and I have 15. We move those numbers, we are moving those coefficients because they were raised to a negative power. That's why we moved them. Okay? X to the first stays. Why does it stay? Because it's positive. Okay? X to the -1, where does it go? To the top. Okay? Y squared, or y to the -2, where does it go?
Goes to the bottom.
It does. And then my y to the 4th stays in the bottom. Okay. Now all my negative exponents are dealt with. 5 and 15, they cancel. 5 goes into 5 1. 5 goes into 15 3 times. Okay, what am I left with in the top?
X squared.
Good. I think I made a mistake with my y's. No, maybe not. Okay. And then I have 3 y to the, good. Okay. Now, Another way to do it, this is option 2. Option 2 is to simplify everything inside the parentheses before I deal with that negative 1. So I've got 15, x minus 1, whoops, x, that's not x minus 1. That is x to the negative 1 power. That's what that is. Then I have y squared over 5x times y to the negative 4th. So what I'm going to do, before I deal with this, before I deal with that negative 1, I'm going to move everything around inside the parentheses. So the first thing that I can deal with is this 15 and 5. What's 15 divided by 5? 3. Okay? So I have dealt with my 15 and I've dealt with my 3. Now, I've got x to the negative 1 and I have x in the denominator. So when I am dividing exponents with the same base, I can do x, whoops, x negative 1 minus 1. Because remember, that's to the first power. That gives me x to the negative 2. Where does x to the negative 2 go?
Goes to the bottom.
So then I have x squared right here. Okay? Here I have y to the second and y to the negative 4. So I have y to the second minus negative 4. That gives me y to the what?
6.
Good. And that goes numerator or denominator? Good. Okay. Now I'm raising all of this to the negative 1 power. So I have 3 to the negative 1, y to the negative 6, x to the negative 2. Did I get exactly the same thing? I did. So you can do it either way. You're completely fine with doing that either way. Okay, now, can I go to the next screen? What I want you to do before we leave, so I want you to write down 1 squared. I want you to write the answer to these. 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 13 or 12 squared. You can use your calculator. 13, 14, 15. Okay? So I want you to write down the square of each of these. What is 1 squared? What is 2 squared? What is 3 squared? Whoa, yeah, that's right. $14 squared is 196, right? 15 is 225. Okay. Now, do you see the stuff in red? Do you see the stuff in red? Those are perfect squares. Those are perfect squares. We are going to start on Monday looking at the perfect squares and taking the square root of perfect squares. We're also going to be breaking down larger numbers, not into primes, which we've done before, but we're going to be breaking larger numbers down into perfect square factors. So recognizing what a perfect square is going to be important. The red numbers are your perfect squares. Okay? Now, you should be able to do the first part, at least 1 through 17 odd. I actually think you can do 23 through 33, but I don't have it right in front of me. You definitely can do 1 through 17. Okay? Have a great day. I'll see you on Monday.